Hello everyone, welcome to another video on shell coding on ARM Assembly Linux 32-bit codes presented on YouTube. So in this video we are going to finally create our first Hello World assembly program. So what are the prerequisites which we wanted to know for creating our first Hello World assembly program? So we need to just keep in mind about the structure which we want to use in our assembly programs, and we can say those structures as a part of program layout, where we have to declare some sections which have their own usages, like the data section is used to store initialized data, BSS section for uninitialized data, text section for the instructions for our program. If you are familiar with any kind of programming language like C or Java, you declare variables for your program. So any variable declaration which you use in your program is called initialized data and is stored in data section. Any data which is dynamically allocated for your program is called uninitialized data and is stored in BSS section. All the instructions like the printf, scanf, just decompile at the ARM assembly at the very base are stored in the text section. So the only two instructions which you may need to know yet are the move and load register instructions. I know I have not created any kind of video related to instructions, but for creating a simple program we may only need move and load register instruction, because talking about instructions may just delay this video. So I wanted to just introduce the concepts of simple program. So to create a simple program, these two instructions are used at max. So what does move instructions do? Move instruction load data into a destination register from an operand. So what does an operand contains? Operand can be an immediate value, or operand can be a register itself. If you passing immediate value into a register, it has to be just used with a hashtag, because assembler identifies values with hashtag as immediate values. Next, for the load register instruction, there exists a destination register, also a operand inside a parenthesis. So what does this signifies is we are loading the value stored at R2, means R2 can contain any memory address, and the data at that memory address will be stored in R1. So this is the main concept which we need to know about for this simple program. So what do we actually want? We want to just print something called hello world on the terminal, where we have to declare a string hello world in our program. By this we can just easily identify that we are going to use data section for declaring our variable like this. Also writing the ARM instructions like the implementing the writes is called, implementing the exits is called, so that our program doesn't create any kind of error. It will gracefully exit after performing the exits is called. So all the instructions for the write and exit will be stored in text section. So what does write and exit syscall needs? It needs syscall number 4 into R7, which is write, file descriptor which is 1, pointer to the buffer, means the memory address of this string, into the R1, and the size of this string into the R2. Then we have to perform SVC, which will let the values of our registers execute by the kernel to perform execution. Then we have to perform exit syscall. Exit syscall number is 1. We have to pass R7 with 1. The status can be anything which we want to have. You can just simply just think like we are asking the process to return exit status. So the exit status is stored in R0 with any value. So let's move on to the computer screen and let's create the file. So to create our first ARM assembly program, we can use any kind of text editor of the terminal like the Nano or Vim. I am going to use Nano for this video. So we can name our file hello world .s, make sure you end up your file extension with a s so that you can just signify the assembler, just tell the assembler that the file is assembly file identified with the .s extension. So after this, we have to declare some sections which we have just talked about, like the data section, because we have declared a string into our program. So we have to just declare a data section where we have to declare the string. Let's name the variable hello world. After that, we have to declare a string which is done by .ascii assembler directive, because if you just directly declare hello world, it might not seems to be anything, because assembler may not understand what this hello world is. It may just print numbers instead of string onto the terminal. So if we want our program to detect strings into our program, we have to declare .ascii so that assembler can recognize that the piece of code is a string, not a byte or not a hexadecimal byte. Then we have to declare a length variable, which is the third variable in the right syscall. So there is a technique by which we can get the length of this entire string is just use a dot minus name of the variable. So what does this actually do is subtracting the current length minus the variable's data length. So ultimately it will provide the length of the hello world string. But here we have to declare is equal to. If you are using just this technique, dot technique, you have to declare the variable with an is equal to instead of that colon, because it will yell out an error. Then we have to declare a text section to declare the instructions. We are not using BSS section because we are not using any kind of dynamic memory into our programs. So to create an entry point, we have to just declare global underscore start, start that function. In assembly, we can just write comments with @. So we have to implement write syscall, whose syscall number is 4, and store it in R7. As we know, R7 stores the syscall number. Then we have to store the file descriptor into argument 1 or R0, that is 1. Then we have to load the string of this hello world into a register, which is third register or R1, which is load register R1 into the memory address of the variable string hello world. So what does this actually do is load the register R1 with the memory address of this variable. After that, we have to again load the memory address of the length variable into the R2. So we are declaring this. So what does this do is store the memory address of length into R2. Then we have to do a software interrupt by SVC. Then we have to just implement the exit function, which is syscall number 1, moving R7 with immediate value of 1. Do you remember that we have to pass immediate value with a hashtag symbol? Else if I do this, then it will create an error. I have to just assign hashtag to prevent any kind of errors. Then in the first argument, we have to just store the return address which we want to be returned by the process. It can be anything, 0, 1, 2, 3, 4, 5, anything. But for example, I am just returning 11. I will just signify where this 11 is stored. What is the significance of the return value of the exit syscall? After that, we have to perform system interrupt svc0. Now the entire code is complete. We have just printed that string to the terminal. We have gracefully exited the program. Now we are going to assemble this. Save the program. Assemble the program with hello world.o. If you have not viewed the initial setup video, then please view, because this binary is only installed by something called binary utils ARM Linux GNU EABI HF package. So make sure you watch the fourth video of this course, which is on the initial setup, setting up the environment. After assembling the file, we have to just link the file by utility called ld. So by ARM Linux GNU ABI HF ld, output will be hello world. The linking file will be object code file of the hello world. After linking this, the file is properly converted into an executable. Now we can execute that string, and hello world is printed successfully. And if you just wanted to know where the exit status is written, then see, the exit status is 11. This is the significance of the exit status. It just helps user to identify what has the process done. So exit status can be referred to anything like -1 is for error, 0 for success, 1 for anything custom, and many more things. We have just implemented 11 so that I can just demonstrate you what is actually happening. So this was the only thing which I wanted you to understand for creating your first ARM assembly program, which is helloworld.s. So again, I will just give you an overview. We have declared a string variable with as keys, declaring a string, declaring the length variable, which is the third argument of the write syscall, writing the instructions required for our program in the text segment. We have implemented write syscall, passed R7 with the write syscall 4, moved the R0 with 1, which is standard out, loaded the memory address R1 with the memory address of this variable, and R2 with the memory address of this variable. Then perform system interrupt. The data will be written on the terminal, and after that we have gracefully exited the program by passing R7 with 1 and R0 with the return status. That's all for this video. Moving on to the end of this video. If you have any question related to this video, you can ask in the comment section. Drop some likes and subscribe. If you want to download the slides used in this video, you can just refer to the description and download the PDF. Do follow me on GitHub and Twitter as well. That's all for this video. Meet you in the next one.